Alright, this is a quick video over absorbers and countercurrent flow trade towers. The reason they're towers is because, and not a barrel on the side, is because you want to use the density difference between the vapor and the liquid, where the liquid has a much greater density than the vapor, so that, of course, they would want to separate just because of their densities, and so the liquid will go down and the vapor will rise. Now, L prime is the molar flow rate of the solute-free liquid. L prime. So that's going into stage 1. But if none of the solute-free liquid is vaporized, that will be the same as it comes out at the end of the tower. And the same is true for the vapor prime, or V prime. It is the mole flow rate of the solute-free gas carrier, or a carrier gas. And if none of that, the gas carrier itself is not condensed, it will be the same at the top. Now the X is the mole ratio of the solute to solute-free liquid. And if we have clean liquid, this would be X naught, and it would be 0 if it's clean. If clean. The reason it's X naught is because it's going into stage 1. So you just subtract, if it was going into stage 2, it would be X1. If it's going in stage 3, it would be X2. Now it's coming out of stage N, so then it is Xn down here, and of course it's not going to be clean because it has absorbed some of the contaminant from the vapor. And of course, Y is the mole ratio of solute to solute-free gas in the vapor. And this is Yn plus 1, and this is Y1. That is for absorbing, or absorber. For a stripper, we still have our L prime, and of course we're assuming none of the liquid is vaporized, and we're also assuming none of the vapor is vaporized or is condensed. Again, that's the mole of the solute-free gas carrier and the solute-free liquid. Now, it's no longer just X not up here, it's Xn plus 1, and it comes out as X1. We're just changing it up just a little bit so the math becomes a bit easier. And this is now, of course, Y naught and Y N. So these are just some of the nomenclature for the countercurrent flow for a absorber or a stripper. Notice they are different. You can't use the same units, that will mess up your math. But this is just some of the very basics, and we'll start graphing them in the next video.